on how we can calculate the range, how we can calculate the rank, and let's see the most valuable. So let me ask you this question. Find B inverse. If B is equal to 1, 2, 3, 2, 3, 0, and 0, 1, 6. Find B inverse. Oh, okay. No. Can you find first what is the determinant of B? What can you say about determinant of B?
0.
So what is B inverse? Apparently it does not exist. Okay, B inverse does not exist, you cannot find it, because the determinant of B is 0. Now let's assume we have a matrix A, which is 3 by 4, where Aij is equal to -1 to the power I plus -1 to the power j plus I plus j -1. Okay, I just made it up now. Okay. A combination where we want to figure out what is the matrix elements by itself. So let's try to see what this matrix is. What is A11? A11 is equal to -1 to the power 1. We get -1. -1, because -1 to the power 1, this is j, okay? Which means that this, we're writing for I equal to j equal to 1. And we substitute everything in this expression. So wherever we see that I and j, we substitute it over there. We have -1, -1, +1, +1, -1. What is the answer here? -1. And then we have A21. What is A21? Well, let's write, who can help me here? A21?
1.
Then?
-1.
Yes. +2.
+2.
+1. -1. So we get 2, right? So this is 2. And then we have here A31 would be equal to, what is this? -1, -1, +3, +1, -1. What is this? This is 3 minus 2, that's 1. Okay, so actually let's look at this one. If the I is the number of a row, right? So in the first row, in this first row, we have, this is always going to be -1, right? So this is -1, -1, we get -2 from here, and the first row, -2, +1, this is -1, -1, this is a little complex. Actually, I shouldn't have done this one so complex. We could have kept a simpler one, but still we can deduce something. Let's check the first row. Row 1, I is equal to 1, which means that the first term we can simplify like this: -1, -1, we get -2, plus the first element, this is 1 + 1, 2, +2, this is I plus j. Okay. Probably you can do this faster than me. So the first element, it was -2 + 2 -1. What do we get? We get -1. That's correct. Then, if we keep I the same, we move one more further. J, so this -1, we get 1 from the j, it gets 0, plus 2, I guess this is a 2. And then we move ahead, 1 more j, we get from 2, this will become 0, plus 1, I guess this is 1. And then the rest is, today I made quite a few mistakes, okay, like when I write on the board. So I'm sure, I hope I don't do any mistake now. So the A 1, 4, this would be equal to minus 1, plus 1, plus 5, minus 1. So we get here 4, right? We get here 4. And again, just by the way, 1, 3, this would be equal to minus 1, minus 1, minus 1, plus 4. So we get here 1. So this is 1. That's correct. This is 1. So we can build up some logic behind this. So it looks like actually this I plus j minus 1. What is I plus j minus 1? I plus j, if this is 1 plus 1, 2, 3, 4, 5. So this is just I plus j minus 1. We can have here 1, 2, 3, 4 actually. This is 1, 2, 3, 4. Then we come down. This is 2, 3. Then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is just this term here. Let me check. We sum. So this is okay, so we have this part here is this component, and that if we add this minus 1 to the power I to the first column, this will be what is this? First column is all minus 1, minus 1, minus 1, minus 1. Second column, this is I is, sorry, okay, it's plus 1, so this is 1, 1, 1, 1. So we are doing this part now, and this is minus 1, minus 1, minus 1, minus 1, good. Let's add here minus 1 to the power j. Колена е par, është minus 1, колена 2 dhe plus. Okay, kjo është minus 1, minus 1, minus 1, 1, 1, 1, minus 1, minus 1, minus 1, 1, 1, 1. Good. So we have these three matrices, and we should get that little piece of matrix over there. So here we really have minus 1, then 2, then the first one I guess is correct. The second row we get 2, that's, I had a good shot. 4, 5, here we have 5, 4, this is 4, 5, 7, and here we have 3, 1, this is correct 1, then we have 4, 4, we get 4 again. This is so complex, most probably the rank is already 3, but let's see. 5 minus 2, we get 3. We have 5, 6, 6. Okay, good. Okay, we finally did it. Okay, most probably we are correct. It was a very hard task for us. Not very hard, but we could simplify by representing it into matrices, as we did over there. So now the question is this: let's find the rank. Okay, finally, let's come to the rank. How can we do it? We could formulate this in different ways. I would strongly suggest if we multiply by minus 1 to make this a leading one. So this is plus 1, minus, minus, okay, like this. And then we can add, let's see what we get here. This is 1, minus 2, minus 1, minus 4. We can subtract from the second one twice the first one. This is 0, 5, minus plus 4, 9, 4 plus 2, 6, 7 plus 8, 15. Okay, so then the next step, we can do the following. Row 3 minus row 1. What is row 3 minus row 1? 1 minus 1, 0. 4, 6, 3, 4, 6, 10. Okay. Then the next step is we can try to make a leading one. To have a leading one here, we can divide by 9. So we can divide by 9 here. 9, 9. And this is 1 minus 2 minus 1 minus 4. 0, 1, 2 over 3. And this is, what is 15 divided by 9? This is 5 over 3. Okay, and then we have the following. We do the row 3 minus 6 row 2. This is 0.
I think we can divide row 3 by 2 first.
Row 3 by 2, would it help? 5. Okay. 3, 2, yeah. We can do that. We can do it step by step, but if you, this is 3, 2, 5, right? Okay. 3, 2, 5. Now, you know, to distinguish whether two rows are similar, we can calculate the ratio. Why don't we check the following? So this was 9, okay. 9 divided by 3, 6 divided by 2, 15 divided by 5. Is this the same ratio?
Yes.
Yes. So actually, I'm using this before dividing by 9. So it looks like this complex matrix that we just made up together, it looks like it has a rank smaller than 3. The first option is to have rank 3 because we have 3 rows. But then, as we do this row echelon form, we might completely take one out, which apparently it looks like that is going to be the case. Okay. So then most probably we can actually double check. So 9, this would be 1. So this would be this is 2 over 3. So let's see. This is 2. The first element, 3 minus 1. So 3 minus. Okay, we don't do it minus 6. We do minus 3 times the second row. Let's try to write this one like this. We have 3 minus 3 times 1. This is 0. Then we have 2 minus 3 times 6 over 9. Let's see what it's going to be. We have 5 minus 3 times 15 over 9. Okay, so we carefully try to write down row 3 minus 3 times row 2. This is 3. This is, we get 3 here. This 3 goes with 2. This is 0. Then this 3 cancels out. 3 is gone.
0.
0. Okay, good. So it looks like this matrix we made up. What is the rank? Rank is equal to 2. Okay, so we try to, yeah. And then we can simplify this reduced row echelon form a little further. So we have 2 leading ones. This one here, and yeah. This was one spatial exercise, for example. So, but this is very important actually. So to check if two rows are linearly dependent, checking the ratio of the pairs of 2 by 2, all the pairs that are provided, it is a good way. Now, let's give another example. If you have a matrix A, which is equal to A, B, C, D. Find D such that rank of A is equal to 1. So let me write it like the question. I formulated something like this. D is equal to what? Such that rank of A is equal to 1. How can we do that? What would you do here? How could you relate in order to make the rank of A 1? So first of all, if the rank of A is expected to be 1, what does this mean? This means that the second row would be a linear dependence of the first row. So
should we choose a number, for example, m, which multiplies the first two components, A and B, okay, and like m times A is C?
Like this?
Yes. And m times B is the unknown.
That's correct.
From the first equation, we found m. We substitute in the second one, and we find D.
That's true. So you are trying to find a linear relationship between this vector and this vector. And that's correct. So this m here, we can write it with, wait a second. How can I do this one? Well, m would be equal to
C over A.
Yeah, C over A would be equal to D over B, right? Would you agree like here? Or, what did we do in the previous example? We said 9 divided by 2, by 3, So we took the ratio of these numbers with these numbers, and we obtained this, right? Now, similarly, if we want them to be rank 1, we can construct the following. A over C is equal to B over D, right? And then if we see, actually, this is the inverse of this one, because I just took the ratio here, and I want it to be equal. So you are right, we are asked for D, and then D would be equal to what? Okay, BC over A, which means that if A is equal to 2 minus 1, and this is 3, what should this number be?
Minus 3 over 2.
Yes. Minus 1.5, yes. Or we can do it like this. This is it, 2, 6. What do you do? So we are from 2, we multiply by 3. Here we multiply by 3 again. Or you can do 6 divided by 2. Okay? I think, sorry for interrupting, you were saying something, but probably it's to some degree obvious. Now let's see this other example. Let's assume the matrix A is given as follows. Here we have 1, 2, 9, 6, minus 3. Find A if the rank of A is 1.
We first work with the second line. It's 1, 3,
Yes.
and minus 1.5.
Yes, minus 1.5. So we just check for the ratio. From here, we have divided by 2. We divide by 2, we divide by 2. That's good. What about for the first row?
For the first row,
Isn't it 3?
should the rank be 2 or 1?
Would you agree for such a relationship, 9 is equal to 3 over 2 times 6? So we can find the ratio how row 1 is related to row 3. Which means that, I'm looking for the eraser. It would be the following. Row 1, it can be equal to row over 2 times row 3. Would you agree with this? Yes. 3 over 2 times 6, we cancel out. This is what is 3? 3 times 3 is equal to 9. So in this case, what is this number here? This would be 3 over 2 times 2. Okay, we get 3 here. Then we have 3, sorry, this is 3 over 2 times 6 for the second element. This is 9. And 3 over 2 times minus 3, we get minus 9 over
4.5.
Minus 4.5, that's true, okay. So we found another A that has a rank equal to 1. Okay. So we are dealing with a rank. I think we covered quite a few examples with the range. And then okay, so let's assume a case. Given that we have an augmented matrix AB, given in a row echelon 4 as 1, 3, minus 2, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 2, a lot of zeros. This is 0, 2, 0, 3, 3, 1, 0, 1, 5, 0. Okay, so we observe a system of linear equations which has a rank of what? What is the rank here?
4. 3.
Rank is equal, yes. Well, I'm not asked, sorry. I didn't ask the final question. So here we can ask the following. Thank you for your input. What is the rank of A? It looks like it's 3, right? And we have to look only this part. So rank of A is 3. What is the rank of AB? What is the rank of AB?
It's still 3.
It looks like 3.
That's correct, it's 3. So if rank of A is equal to the rank of AB, then we have solution. There is always a solution. The problem could be the following. Imagine for a moment that this number is not 0, but is, let's say, 1. It can be any number. Then this one, we can read it. It goes like this. Then at this stage, we'd say that rank of A would be equal to 3, but rank of AB is what?
4.
Is equal to 4. Now, in this case, we have no solution. Right? Because before, in the first session of today's class, we said that we should be aware of a row that looks like this, 0, 0, 0, it can have a few zeros, and the 1. If this is coming from a row of AB, okay, if we have any row that looks like this, what is our answer?
No solution.
No solution.
That's true. So this one and this one, they both point to the same thing. But this one, apparently, if it is formulated like this, it could even be 5. It doesn't matter anyway, it's the same thing. But let's keep this 0, and let's try to observe to get some, what do we learn from this system? First of all, it looks like A is 4 by what? 1, 2, 3, 4, 5. What is the size of A?
4 by 5.
4 by 5, okay. What is the number of the unknowns?
5.
5. What is the initial number of equations?
4.
4 equations, okay. But how many of these equations they are independent?
4. 3.
3 equations, yes. 3 equations are independent. Independent. Okay, so we have to be careful about this. So we start with 4, yes. But we have 3 equations that are independent, which means that if we have 3 equations that are independent, we could say the following are equivalent. We have 3 leading ones. We have 3 leading ones. We can say rank is 3. What could have been the rank? The rank would have been 4, right? So if we had 4 linearly independent equations, but no, it looks like rank is 3, and it is smaller than, well, what is this? A n by n, I forget.
N.
M by n, yeah, I forget this, so it's less than n.
N, yes.
Yes, okay, so this is less than this. Then, what is the number of free variables?
1.
And we have 5, so if we are to solve this system, we put, what do we do here? We say x1, x2, x3, x4, x5, so this is how we do it, right? So out of these, which ones have a leading one? It's x1, x3, and x5, okay? So let's try to read them here. So how many free variables do we have? 5 minus the rank.
2. Yeah.
We get 2, okay? So in the first session, we had a discussion. What should be the number of free variables? Right? We said the rank minus this. but probably this is more correct because if we see that from x1 to x5, the three leading ones, but the hidden, not hidden. Let's call this three variables. Let's draw this in blue. And this one is also, well, no, this has, in its own column, this has a leading. So x4, x4, there are three variables. Now, we have this matrix. The question is, this is row echelon form. This is not the reduced row echelon form because we can simplify this a little further. How would we simplify this one? What is left? What do you think? What we can do is that we can produce zeros in each column of the leading ones. So this one, că vă pune că vă zero, mă rog. Că nici că vă punctul tu scală până acum, de că nici du bëj zero të gjithë elementet e kolonave, pra do ta spastroj. Kjo është reduced row echelon form, dhe kjo është proporcione më të thjeshta për të zgjedhur. So to do that, let's try, let's see what we get. So we want to make this zero, so or no, let's start with this one first. So we say row 2 star would be equal to, what is this? Row 2 minus 3 row 3. Would you agree with this? Row 2 minus 3 row 3. Okay, if this is the case, and this is relatively easy, we could write this right away. 3 minus 3, this can become 0. And 1 minus 15 is minus 14, right? What do you think? Minus 14. Okay, we simplify this, things look good. And the next step is we want to make this 0, the first row. Let's not write everything over there, but we have here the second row. This is modified, this is 0, 0, 1, 2, 0, minus 14. And here we have 0, 0, 0, 0, 1, 5. All zeros, let's leave them out for a moment. Let's follow with this. The next equation here, we can say that row 1 star, what would the row 1 star be? Row 1, then what?
Plus 2 row 2.
That's correct, plus 2 row 2. So we get here 1, 3. 1, 3. We get here a 0 because it's plus twice. This would be what? 4, 0. This is, what is the rest? Minus 28. Minus 28. Can we simplify this any further? It looks like no, because all the leading ones, they are alone in their own respective columns, okay? So this is the best we can do. And then, if you are to write down the equations that we obtain from here, we have
X plus 3y.
Oh, sure. Okay, we say x1 plus 3x2.
3x2, yes. Plus 4x3.
4x4.
Yes, is equal to minus 20.
That's correct. And then?
X3.
Yes.
Plus 2x4.
Yes. And the rest, x5
is equal to 5.
Equal to 5. That's true. So, and we have also, what is x2? Equal to s. What is x4?
E.
We can write them like this, okay? So, if this is like this, then x3, no, I made a mistake. No, wait. X2 and x4, right? This is correct. Here, no, everything looks good. So, the next step is we need to write x1, x2, x3, x4, and x5. This is all equal to a constant vector plus s plus t.
But for x4, isn't x4 known? Because in the first two equations we have x4.
Well, x4 is a free variable, right? So x4, so leading ones are 1, 1, 1 here. x2 and x4, they are free variables. So it's any number. We cannot constrain it. So here, x4, we can write here t, 4t, okay? And this x4, we can write another t. And x2 is s. So this is, we can write this one s. And this is all, okay. So what is x1? x1 is minus 28. And then what? Minus 3, minus 4. x2 is s, 0, 1, 0. This is s. x3 is equal to minus 14. 0, minus 2. x4 is equal to what?
0, 0, 1.
That's good, okay. And x5?
5, 0, 0.
That's true, okay. 5, 0, 0. Yes. Okay, so it looks like the solution space. What is the solution?
It's a plane.
It's a plane. It's two-dimensional structure, or of course, two-dimensional plane. It's a plane, yes. It's a plane, that's good. And the dimension of the solution space, it depends on the number of free variables. If we had a larger number of equations, if we had 3 variables, then we would be able to construct a 3-dimensional structure inside a 5-dimensional space. Okay, so which is hard for us to perceive, but it is possible if the number of equations is a little larger. Okay, so I think it's good to also to notice, to keep track of this, all of these that we have written here. So A was 4 by 5, N was 5. We had 4 equations initially. Everything was simplified. We get 3 leading ones. This means that this is the rank. Okay, 3 leading ones is the rank here, which is smaller than M, smaller than the first possible value that it could have been. And yeah, just give me 1 second. Do you have any question for what we have on the board?
No.
Okay. Is there anything which is not clear for what we have done so far? Next time we have a quiz. Next session. I'm just going over a few notes. Apologize. Okay, so this was the solution space. Well, I have a couple of examples, but they will just be more exercises on the same issue. So if you don't have any more questions, we can close it for today. And I strongly suggest you to go over chapter 4 in the book, and you can solve the examples that are offered. The examples in our textbook, they are also denoted as activities, I think, and also exercises and examples. So there are 3 different types of things that you can do. Yeah. Okay, so if you have no more questions, I think we can close it here. Moeten we close the